So it says find the exact area of a circle with a diameter of 1.4 inches. So remember that the diameter, and the central angle of 225 degrees. So remember that the diameter is equal to 2 times the radius, right? But my formula for area is equal to 1/2 times the radius times theta in radians, right? So we'll just jump back here so you guys can see that, right? 1/2 times the radius. Oh, I'm sorry, I forgot the square of the radius. My bad. Times the radius squared times theta, and it has to be in radians. So I need the radius is where I'm going with this. So algebraically, if I solve this equation for the radius is equal to the diameter divided by 2. In other words, my radius is equal to 1.4 divided by 2, and so that would be 0.7 inches. So my little thing right here goes to 0.7 inches. The radius equals 0.7 inches. Okay, that's the first part. The next part is I need to convert 225 degrees into radians. Well, I know that the relationship between radians and degrees is 180 degrees is equal to pi. I put the 180 on the bottom because I want to cancel the degrees. So now I'm going to leave this as an exact value, although I could approximate this. And so it says find the exact area. It doesn't say round to the nearest decimal. It doesn't say, the approximate value or anything like that. It says the exact. So whenever you see the word exact, that means you're probably going to have pi in the answer. So we just leave it like that. So that means that I'm going to have 225 over 180 times pi. So we need to reduce that, right, as a fraction. So I'm going to zoom in. Well, let's just do it up here. So if I say 225 over 180, I know that 5 goes into both of them. Maybe, I don't know, something else goes into both of them. Maybe 45 goes into both of them. Let's see. I think 45 goes into both of them. Let's see. So if I say 225 divided by 45, okay, and then 180 divided by 45, yeah, it's 5 over 4. So this whole thing reduces down to 5 over 4. So you might say to yourself, Mr. Adams, how would I know to divide by 45? You wouldn't. You would divide by 5 and then divide by 5. Eventually, you would land on 5 over 4. But usually these problems are rigged up to use one of the special triangles, and 45 seems right. Plus, I've been teaching math a long time. I've kind of memorized some of these tables. I've memorized numbers, and to me it's like 3 times 2 is 6. Anyways, this reduces down to 5 over 4 pi. And so that's our angle. All right, 5 over 4 pi. So I'm rotating around. It's a little bit more than a straight line. In fact, it's 45 degrees more than 180 degrees. 5 over 4 pi. So now we plug it in. I say that the area is equal to 1/2 times the radius squared, which is 0.7 squared, times 5 over 4 pi. Now we are going to get a decimal, but when it says exact area, we're just going to leave all that stuff in here. Okay. In other words, we're going to get a decimal because what's 0.7 squared? Isn't that 4.9? Oh, 0.49. Yeah, that would make sense. 0.49. So, and then we need to multiply that by 5. So 2.45 divided by 8. That's a weird thing to have a decimal and then leave it as pi. That's what they want to do, though. So now you might say, well, let's just leave it as. That's a weird thing to do. Let me think for a second. Yeah, we'll just leave it as 0.3625, which is actually a fraction. Yeah, it's the 2.45 divided by 8 pi. And you might say, well, Mr. Adams, how is that an exact value? You have a decimal. It's a terminating decimal. Yes?
Why did you multiply by 5?
Oh, okay. So, sorry. This becomes 0.49. Whoops. This becomes 0.49. So what's 1 times this? 0.49. And then 0.49 times 5. Then I divide it by 8 because 2 times 4 is 8. And I got a decimal. So an exact value, the reason it's an exact value for two reasons. One, this is what we call terminating. That means that the decimal doesn't go on forever. So we can use it. That's a number. It's a real number. It's actually 2.45 over 8. You could think of it as, you can multiply by 100 if you didn't want a decimal. But pi is an irrational number. And so as soon as I go to convert that to a decimal, I have to approximate because it doesn't terminate. So this is the actual exact value. Now, probably in the textbook, it's so weird that they would do it this way and give you a decimal. But anyways, that's the answer. Does anybody have any questions? Usually they rig the problems up so it's not confusing. But there's a very valid point there. You can have a decimal if it's terminating. But what makes it an exact value is you have an